Good morning, all panel members, colleagues. First of all, thanks to the organizing team for organizing this conference. I am Siddharth Singh Bhadoria from DTU, and today I am here to give a presentation on the topic real-time face detection and face recognition, a study of approaches in this conference. So now coming to our motivation part. So in this digitalized age, like where almost everything is possible virtually, so one needs to be more careful about the security of their digital gadget. Meanwhile, when there are increased cases of theft in ATM and security breaches in phone and etc. So along with this, during this COVID times, like when coming out of home was risky, like even KYCs are done virtually. So these all applications interested us to study about how these things are possible and how can we play our part in making it more secure and feasible. So we thought to study about the face detection and face recognition techniques. When I say face detection, it means that we are looking at a frame and the device tells us that there is a face detected. It has nothing to do with that whose face is this. But the moment it tells that whose face is that, it also recognizes it, and that is face recognition. So this is the basic idea about our research. Furthermore, we will discuss more about that how we find region of interest in the frame and mark it for further processing to match it with other data inputs and then recognizing it. Now these are the different approaches we looked after in our research. For face detection, we looked for a feature-based approach, which looks after spatial features. Like these features require space, such as different grayscale contours for different features of face, such as eyes, ears, nose, and it also looks for the adjacent contours in the images. We may also use a different template to detect a face for feature-based approach method. Then we have geometry-based approach where we look after the geometry of different components of human face, such as eyes are oval, nose is straight, lips are of different shape. So we match them individually and then perform a detection. So that is geometry-based approach for us. And the third and the most important one is hard-like feature-based face detection. It works on the principle of five rectangles, which can be slightly rotated over the entire face, and that looks for five regions of image that are up, down, left, right, horizontally, middle, vertically, middle, and diagonally, as we can see in the image too. So in these rectangles, the dark and light regions generally work on the fact that the area belonging to eyes in the image is generally darker than the cheeks, whereas the region of nose is quite blazing. So to detect a face, when an up-down rectangle will scan over the region of eyes and cheek, it will see similarity with its pattern. Similarly, other rectangles will have their zones to find similarity. And if every rectangle satisfies their condition, then our face will be detected. So this is what we found about this face detection techniques. So when we compared of face detection techniques, these different approaches, we found out some merits and demerits. So in merits, we found that for feature-based face detection, it was highly accurate and it was taking less implementation time, but it was taking much learning time. For geometry-based face detection, it was more effective, execution time is less, but on the other hand, false detection rate was high and it was less precise. For hard-like feature-based face detection, it has much better feature extraction part and false detection rate is low, but it's very complicated process to perform, and it is also time-taking approach. After this, like we compared a different face recognition techniques too. The first one is the lazy learners approach, which is nothing but k nearest neighbor algorithm. So it basically works on the classification of images based on the looking on its k nearest surroundings. So for finding nearest neighbors, we calculated Euclidean distances. Doing that, we will get k nearest neighbors. Then we computed the probabilities for these neighbors based on their similarity with the test data. And then finally, based on the probabilities, we label it to the image of the person it belongs to. So this is the face recognition thing. Next is the human learning approach or the neural network approach. So this approach is based on the principle of human brain. That is, as human brain consists of neurons, in this approach known as artificial neural network, we make our image vector as the input layer and then we add some hidden layers whose task is to find some definite pattern for images and then classify the image that it belongs to which person. Third one is comprehensive approach, like which looks for the entire face. Like it doesn't look for other components of the face, it looks for the entire face rather than looking for different features or components. In this approach, we create eigen faces first, in which we derive a feature vector, like out of the image in form of a covariance matrix, and then train our model based on this. Like when we are provided with some new face for recognition, this approach looks into the weight of the stored images and then compare it with all of them, and then recognizes that whose face it actually is. And when we done some comparison of these face recognition approaches, we found out that this lazy learners approach was more accurate, and it was requiring no training time. But like DMA search, it was taking time in classification, and there was no reusability of parameter values. For neural networks approach, it was less accurate than KNN, and the reusability of parameter values was good. Similarly, DMA it was requiring so many hyperparameters. Training was very expensive for neural networks approach. If you talk about comprehensive approach, it works well with feature extraction, while it was more sensitive to variations in shape of face. Like when we are laughing, when we are in sad mode, when we are screaming, at that point our the shape or face may change. Then at that point of time, comprehensive approach might not work very well. So this all things we got about this. Now, coming to the methodology part, yes, we have three steps to follow to implement as the things we discussed. Our first step will be to gather as much data as possible, which we did using OpenCV. We will capture the faces and save them in some, let's say, face directory. And then for every new face sample stored, we name that is name.npy. Basically, name is the name of the person in that picture, and .npy is for storing that image after converting it in numpy array. Numpy array is that like numpy is a library in Python. So we'll convert that into numpy array, and then we will store that. We will run that script few times to capture some various different faces we are showing, and all these captured images in the frame will act as our data set. So basically, we are storing these images to increase our data set. Yes. After this, we will use a pre-trained classifier for face and eyes, which is already provided in OpenCV, and we can get them easily by har cascades directory. So basically, OpenCV provides a cascade classifier method which imports the model from its GitHub repository. Then we write a method which will accept an image and uses the model to detect the faces in the image. The method first converts the image to grayscale format, as they consist of a single layer. Then we will use this grayscale data with the model imported. It will produce a list of coordinates for all the faces found in the photo. We iterate on each of the entries in the coordinate list. It contains the x and y coordinates and the width and the height. Then we create a rectangle with these values, and this is a reason of interest we talked about in our introduction thing. So this was a reason of interest. Now coming to the face recognition. So as our data set is almost ready with some images, so we framed a face recognition model now, where we will use a k-nearest neighbor algorithm to find out the most optimal face matching throughout our data set to the faces visible in the webcam. We took our k to be 5 after performing some calculations, and then from the test image we will compute Euclidean distances, like for each pre-stored numpy array along with the labels, and whichever face will be more likely, that will be shown as the output to us. After that, we will find out the label which occurred most times in that predicted label, and depending on those values, we simply deflected the change in our already running webcam and then stored the name of the directed person in the frame. So after detecting it, if I'm coming the web frame, that model will show that this rectangular face, this face, but detect it and then show that its name is Siddharth. So this is how it will do it. So here we are providing with some snippets of the data collection images. So this is my face. I'm writing its name as Siddharth, and this is for some other person whose name is Mohini. Then and I also state the name of this person, Sachin. So when I'm in the result section, when I put my face in front of this, so it was detecting the face in this yellow rectangle and also giving the name, the Siddhartha. It is detecting the face and then the name Sachin. So this is how this model is working. Then we comes to the confusion part. So our model basically aims to solve a daily basis of face detection problem which occurs at offices, colleges, schools, and many such places. And it's not only limited to this. It can also be found very helpful in various other issues, such as security scans and eKYC, and it's also very helpful in smart cards. So we can use it anywhere. Like face detection and recognition is used in many places nowadays. Like further, what further improvements we can make in our model? So basically, to improve the accuracy of our model, we can further use the concepts of deep learning to enhance its accuracy. And like if we have used the value of k to be 5, so if we will use multi values of k, then we will be able to optimize our results. And the main thing we can do, like rather than working on the grayscale image, like we're converting our image to grayscale image, we don't have to do that. We can simply work on the original image. So it will be though more computational, but it will give better results. So these are things we can improve further. So these are some of the references we used. And thank you so much for listening to me. And once again, so much thank you for providing us platform to project our research. Thank you so much.